How about them Cowboys? I just had to say it. All right, so on our warm-up, given a table, can you get an equation? Now, we've done it for linear. So if you try to do this the linear way by doing the little bird beaks, you may notice it doesn't work. Check it out. From 2 up to 6 is adding 4. From 6 up to 18 is adding 12. And from 18 up to 54 is 36, I believe. So when we add, I am recording. Please be quiet. Thank you so much. Do it quietly. You can do it. When we add, okay, is it the same thing each time? If you're looking at your phone, you're not looking at the right thing. So if you add the same number, if you're not adding the same number each time, it is not linear. So check it out. Not linear. And so the thing we're doing right now, exponentials, it's in your goal for the day, right? Objective. We need to figure out what's the common ratio, which is what it's multiplying by. So what is it multiplying by each time? Hey, are you typing me the answer over there on that phone? No, or no. So how much are we multiplying by each time? Very large class of mine. How much are we multiplying by each time? Okay, someone muttered it. You can be a little bit more confident. It's 3. 2 times 3 is 6. I know y'all know this. Hey, don't be afraid. So 6 times what is 18? Okay, 3. You get the idea. It's multiplying by 3 each time. When the y values are multiplying each time, that's exponential. Okay? So if you remember, our function is a times b to the power of x. Okay? Now, I'm telling you this. The multiplier is the b value. Okay? This is my b value. So in my equation, I just figured out the b. Do y'all remember what the a stands for in this table here? The y-intercept when x is 0, right? So when x is 0, now I'll have some people think it's always the top one. No, not always the top one. It's when x is 0, the y value is 6. That's my a value, the 6, okay? So if I know a is 6 and I know b is 3, can I write my equation a times b to the x? Yes. So let's do that down here. y equals a times b to the power of x. So what am I going to write? What's my a value? Okay, y equals 6, parentheses, what's my b value? My multiplier, 3, and then I can't forget to put power of x, okay? So that's how I got an exponential equation from a table, okay? Now, we will eventually learn how to do it with a regression, kind of like we did with menu 413 in the spreadsheets, but we're not there yet, okay? We're just doing it from a table. Now, number 2, is it subtracting by the same number each time? 24 down to 12 is subtracting 12. It doesn't keep subtracting 12, otherwise this 6 would be a 0 instead, right? So it's not linear. And since it's going down, I got to think about this. What's happening each time? What do you think? Okay, decay is fine, but what's dividing, okay, by dividing by 2. Okay, yes, kind of. I mean, yes, but we want to think of this as multiplying. Since we want to think of it as multiplying, what is dividing by 2 the same as multiplying what? A half, okay? Times a half. So again, dividing by 2 is the same thing as multiplying by a half, okay? Now, that's very important because if you put 2 as your b value, that's so wrong, okay? So don't think about what am I dividing by, it's what am I multiplying by. Okay, what's my, that's my b value, what's my a value, what am I starting at? When x is 0, my a value is my y value. So what's my final equation going to be? 24. Now, if you put 1/2 fraction, that's what I'd like. You know, if you put 0.5 as a decimal, that's still technically fine, but put 1/2 and then power of x. All right, 24 times 1/2 to the power of x. Now, last class we did notes for most of the class, and a little bit at the end I gave you the assignment. But I'm giving you this class period to finish the assignment from Friday, I should say. So here's the deal. If you weren't here or you lost it, you can get it out of the blue bin. There's 2 folders that say 917. One is a notes. If you want the filled out notes, they're in there. There's also the assignment in there. You need to work on that and finish it today, and then you also need to finish missing work.